Hi everyone, welcome to section 8.2. In this section, we are going to be working on the continuation of systems of equations. Now, this time we are interested in solving a system of linear equations in 3 variables instead of 2 variables, and we're also going to be looking at applications. So the first question, it looks very similar to the first question that was in section 8.2, which was to determine whether this order triple instead of x and y, it's not going to be x, y, and z. This order triple, is that a solution? Does that satisfy this system of equations? So the first thing that we want to do is to check if the point 0, -2, and 5 satisfy. So x will be 0, y will be -2, and z will be 5. So for the first one, we have 0 minus 4 times -2 plus 5. Does that give you 13? And then 3 times 0 minus a -2, plus a -2 minus 5. Does that give me -7? And then last one, it's 2 times 0 plus 3 times a -2 plus a 5. Does that give you -1? So let's start 0, and then I have a -2. That's negative times a negative is a +8. +8 plus 5, does that give you 13? 13 equal 13? Yes, the first equation satisfy. The next one, it's 3 times 0, that's 0. I have a -2 minus 5. Does that give me a -7? Yes. -7 is equal to -7. They are both true. And the last one, 2 times 0 is 0. 3 times a -2, that's a -6 plus 5. That's a -1. Does that equal -1? Yes. So all of those 3 equations has been satisfied. Now, this is just to check. Now, the way that we solve a system of 3 equations and 3 unknowns is we choose a pair of equations to eliminate one of the variables by using the addition method. So the way that we are going to be solving a system of 3 equations and 3 unknowns is we are going to be combining 2 equations. What I like to do is I combine equation 1, equation 2, and equation 3. You grab a pair, so you grab equation 1 and equation 2. And you want to pick which variable you want to cancel. So you always want to stick with combining eliminating the same variable. So I have x plus y minus z is equal to -4. And then I have 2x minus y minus z equal -7. I want to eliminate z. So to eliminate z, I'm going to multiply the bottom equation by a -1. When I do that, I have x plus y minus z equal -4. -2x plus y plus z equals 7. And then I get -x plus 2y. The z will cancel, is equal to +3. This is going to be my new equation 4. Then I'm going to combine equations 1 and equations 3. So I have x plus y minus z equal -4, x plus 6y plus 2z equal -1. Again, I'm going to stick with the same variable that I'm going to eliminate. I'm going to eliminate z. To eliminate z, I have to multiply the top by number 2. So then I have 2x plus 2y minus 2z equal -8. And then on the bottom, I have nothing changed, x plus 6y plus 2z equal -1. So here I get 3x plus 8y is equal to -9. And that will be my new equation 5. So now I have equation 4 and equation 5 that I will combine because now they only have variables x and y. And this becomes a question from section 8.1. So now I have equations 4 and 5. So that's -x plus 2y is equal to 3. 3x plus 8y equal -9. Now what I want to do is I want to eliminate x. So I'm going to multiply that equation by a +3. If I multiply it by a positive 3, I'm going to get negative 3x plus 6y equal 9, and then 3x plus 8y equal negative 9. So here I get this 0, 14y equals 0. That gives me y to be 0. So since we solve for y, to be 0, I have to back substitute into equation 4 or 5. So then you're going to substitute the values. So you're going to back substitute the solution into equation 4 or 5. I'm going to plug it in equation 4. So it's negative x plus 2y equal 3. Negative x plus 2 times 0 equal 3. So it's negative x equal 3. That gives me x to be negative 3. Okay. Well, now I have one solution, two solutions. I'm missing one solution. So then, since I have x to be negative 3, so x is negative 3, y is 0, I have to find z. So I'm going to plug it into equation 1. So back substitute into either equations 1, 2, or 3 into equation 1. So equation 1 was x plus y minus z. X plus y minus z is equal to negative 4. So I'm substituting y to be 0 and x to be negative 3. So it's negative 3 plus 0 minus z equal negative 4. So then bring the 3 over by adding. I get negative z is equal to negative 1. Then divide both sides by negative 1. I get z equal 1. So my solution, my order triple is negative 3, comma 0, comma 1. So my solution becomes this order triple. Negative 3, comma 0, comma 1. And that is the first way I want to solve my system of 3 equations and 3 unknowns. So let's move on to question 2. For question 2, we have to do some pre-work. That pre-work, we want to undo and get rid of that denominator. So I'm going to multiply by the common denominator, which is the LCD, which is 6. When I multiply by 6, I get 6x minus 3y. So half of 6 is 3. And then 1/3 of 6 is 2, is equal to 30. And then everything kind of goes down. X minus y minus z equal negative 1. And then I have 6x. See how this plus 3y, I have to move it over, plus 3y plus z equals 0. So I had to change the order and make sure that I line everything up accordingly. That's the one, and that's what I call my pre-work. So there's things that I have to do before I actually attempt to do my system of equations. Then the next thing I do is I label my equations, equation 1, equation 2, and equation 3. And then I start combining equation 1 and equation 2. So I have 6x minus 3y plus 2z equal 30. And then I have x minus y minus z is equal to negative 1. I want to, again, I'm going to eliminate my z. I'm going to eliminate my z by multiplying the bottom by a positive 2. So then I have 6x minus 3y plus 2z equal 30. And then I have 2x minus 2y minus 2z is equal to negative 2. And then I have 8x, use the addition method, negative 5y. The plus 2z, the minus 2z will cancel, is equal to 28. And that's my new equation 4. I combine equations 1 and 2 to make equation 4. Then I combine equations 1 and equation 3. And then I have 6x minus 3y plus 2z equal 30. And equation 3, it's 6x minus, it's the third equation, 6x plus 3y plus z equals 0. You're like, I really want to cancel the y. You cannot. So you need to eliminate z. You need to stay consistent. If you do not stay consistent, then you're going to get the wrong answer. So if I want to eliminate z, I'm going to multiply the bottom equation by a negative 2. So the top is 6x minus 3y plus 2z equal 30. The bottom equation, if I multiply negative 2, it's negative 12x minus 6y minus 2z equals 0. Then I get negative 6x, a minus 9y, the z's will cancel, is equal to 30. And that's my new equation 5. So see how I now have equations 4 and equations 5 that I need to combine. So if I combine equations 4 and 5, I get 8x minus 5y equal 28, negative 6x minus 9y equal 30. Now the next thing is, what do I want to cancel? I want to cancel my x. I'm going to multiply the top by 3, the bottom by 4. So then they become 24. So the top is 24x minus 15y equal 28 times 3. Let's go ahead and multiply. What's 28 times 3? So we get 28 times 3. And then we get 28 times 3, 84. And then on the bottom, negative 24x minus 36y is equal to 120. Now the 24x's will cancel. I will get 15y. So I have a 15 and a positive 36 that I add, and 51, negative 51y is equal to, if I add 84 and 180, sorry, 84 and 120, I get 204. And then if I divide 204 by 51, I get 4. So y is negative 4. So if I divide both sides by negative 51, I get y to be negative 4. And negative 4 becomes my solution for y. Now I'm going to substitute. I have to back substitute into either equation 4 or 5. I'm going to plug it into equation 4. So it's going to be 8x minus 5y equal 28. But I'm substituting negative 4, so it's 8x minus 5 times negative 4 equal 28. So make sure you're bookkeeping. That's very important. I get 8x plus 20 is equal to 28. Subtract both sides by 20. I get 8x is equal to 8. And then divide. I get x equal 1. Now I have my x and I have my y. I have to back substitute x and y into equations 1, 2, or 3. So then again, I'm back substituting. And I'm going to decide to choose equation 2. So I'm going to substitute in equation 2. It's x minus y minus z equal negative 1. But I have x and y. 1 minus 4 minus z equal negative 1. I have a 5 because 1 minus minus is a plus, so it's 5 minus z equal negative 1. Bring the 5 over, negative z is equal to positive 4. Sorry, so it's bring it over by subtracting, and that gives me negative 6. So it's minus 5 here, negative 6. So divide both sides by negative 1. I get z equals 6. So my order triple, my solution, if you will, my solution is going to be the point 1, comma, negative 4, comma 6. And that is the solution. It's a unique solution of 1 only. So that's 1 and 2. So let's try 3, 4, 5, 6, and 7. So we still have a few more to go. So I'll pause that right now. Hello, everyone. Welcome to section 8.2. This should be the continuation, so this is part 2. Let's begin by recalling that we're interested in eliminating a variable and making sure that we have an order triple. So this is equation 1, equation 2, and equation 3. If you notice, equation 2 and 3, we're able to combine because we can cancel and eliminate z. So if we combine equations 2 and equations 3, we get 2x minus z is equal to 4, and then x plus y plus z is equal to 29. Notice that I have the addition method, so x plus 2x is 3x, and then I have a plus y. I don't have a y to eliminate, and the z's will eliminate, is equal to 33. That gives me equation 4. Now, equation 4 and equation 1 only have variables x and y. So we're going to combine equation 1 and equation 4. So I have x plus y equal 19 and 3x plus y equal 33. I'm going to go ahead and eliminate the variable y. So if I want to cancel the y, I'm going to multiply the top by a -1. So I'll have negative x minus y equal negative 19. On the other side, I'll have 3x plus y equal 33. I'm going to go ahead and combine like terms. I'm going to get 2x is equal to, if I have 33 minus 19, that gives me 14. So I solve for x and I get 7. So then, once I solve for one variable, I need to back substitute. When I back substitute, I'm going to substitute it in either equation 4 or equation 1. I'm going to plug it in into equation 1. So I have x plus y equal 19. So then I have 7 plus y equal 19. That makes me solve for y. So subtract both sides by 7. I get y equal 12. So I solve for x and y. All I need is to solve for z. So what I'm going to do is I'm going to back substitute. I'm going to use x equals 7 and y equal 12 to plug it to, I'm going to substitute or plug in equation 3. So then I have x plus y plus z equal 29. So I have x to be 7, y to be 12. I'm missing z, so I combine 7 and 12. That gives me 19 plus z equal 29. Let's go ahead and solve for z by subtracting both sides by 19. That gives me 10. So I find my order triple to be 7, 12, 10. And that is a unique solution. That means there's an intersection between those 3 lines. Okay. All righty, so let's move on to the next question. Now, the next question looks a little bit different because it's not in the order we're used to seeing it. So the first thing we want to do is rewrite in standard form. What does that mean? If we're writing it in standard form, that means I want ax plus by plus cz equal d, where I want all of the variables on one side and all of the numbers on the other, the constants. So what I'm going to do is I'm going to bring everything to one single side. I'm going to bring the 3 over and the y over. So then I'll have for the first equation to be negative 2x minus y plus 3z equal 3. And then I will have the next equation. I'm going to do some prep work. So I'm going to clean it up and I'll have 4x minus 6z plus 2y equal negative 6. And then here I'll have everything is almost right except the order. So it looks like this is 3x, like so, 3x minus 2y plus 4z plus 4z will give me 1. So then we are working with the following. We're going to have negative 2x minus y plus 3z is equal to 3. And then I have 4x minus, or plus, excuse me, plus 2y minus 6z equal negative 6. And then I have 3x minus 2y plus 4z is equal to 1. So then notice if I look at equation 1 and equation 2, if I multiply equation 1 by the value 2, I get negative 4x minus 2y plus 6z is equal to 6. And then the bottom, it's 4x plus 2y minus 6z is equal to negative 6. Now, if I add equations 1 and equation 2, after trying that addition property, what do I notice about this? Well, I notice the fact that they all cancel. 0, I get a 0 on here, they cancel, and I get 0 equals 0. This gives me infinite solutions. That means that we have dependence. Now, notice that one of the variables, y, is already kind of solved for in terms of two variables. We want it to have it in one variables. So to find the general solution, what we're going to be doing is I'm going to add equations 1 and equations 3. So equations 1 and equation 3. So notice on the negative equation 1, which is negative 2x minus y plus 3z equal 3. And then equation 3, we have 3x minus 2y plus 4z equal 1. I'm going to multiply times 2 on the top. So I'm going to cancel the y. I'm going to actually multiply by a negative 2. So it's going to be 4x. So what I'm doing is I'm trying to cancel one of the variables. So I'm going to cancel y. So that way, since I already have a generic form for y, then I'm interested in having everyone to be the single one variable. So if I multiply by negative 2, I'll get 4x positive. See, there's a negative. And then a plus 2y minus 6z equal negative 6. And then you're going to go 3x minus 2y plus 4z equal 1. Let's go ahead and add these together. I get 7x, so 7x. I will cancel my y's. Minus 2z is going to be negative 5. So now I have almost something in terms of one single variable. So I'm going to solve for z. Because I'm going to solve for z for both of these cases. So what I'm going to do is I'm going to bring it to the other side. I'm going to solve for z. So I have 7x plus 5 equal 2z. Divide both sides by 2, and I get z to be 7x plus 5 over 2. So I know what z is. Now, if I go into my y, I know that y is equal to 3z minus 2x, 3z minus 2x minus 3. Now I'm going to substitute the value of z in there. So y is going to be equal to 3 times 7x plus 5 over 2 minus 2x minus 3. Notice that all of them is in terms of x. So x is the independent. So x is the independent variable. And everyone else, y and z, depend on x. So then I'm going to solve for this, and I'm going to solve everything in terms of x. So I get y equal, and my pen is giving me some issues here. So if I go into cleaning it up, let me clean this up, and I get y is equal to, I'm going to distribute the 3 out. So that's going to be 21x plus 15 all over 2 minus 2x minus 3. Now I'm going to have to combine them, and I get y. So using fractions here, I'll have y equal 21x over 2 minus 2x is the same as 4x over 2 plus 15 over 2 minus, well, 3 is 6 over 2. So you combine like terms in a single denominator. So then I have 21 and 4, that's 17x over 2. And then plus 5 minus 6, it's a plus 9 over 2. So then y is going to be 17x plus 9 all over 2. So then my final solution is going to be my x, which is independent, my y, which is 17x over 2 plus 9 over 2, comma, my z solution in terms of x, so it's 7x over 2 plus 5 halves, where x is any real number. And that is how I'm going to have my solution. It's x, y, and z, but they are all in terms of a single variable. And that single variable was the variable x. So you kind of get an idea once you already have a variable. See how this y is already kind of solved for in terms of other variables? That kind of gives you a hint. Make sure that you rewrite this in standard form and be able to identify what are the steps you need to do. And once you get a 0 over 0, you know that you're going to have an infinitely many number of solutions or a dependent system. So the system will be independent. So it'd be dependent. And that is solution number 4. Now, for solution number 5, the way that we work with question number 5 is, again, very similar. It's important for you to name your equations, equation 1, equation 2, and equation 3. So first, you're going to combine equations 1 and 2. So 3x plus 2y plus z equal 3. And then x minus 3y plus z equal 4. Now I'm going to multiply, and I want to get rid of my z. So I want to eliminate z. So when I eliminate z, I'm going to multiply it by -1 on the top. So it's negative 3x minus 2y minus z equal -3. On the bottom, I'm going to have x minus 3y plus z equal 4. I'm going to add addition. So it's negative 2x minus 5y is equal to 1. So that's equation 4. And now I'm going to combine equations 1 and 3. Righty, so we are interested in, we combined it equation 1 and equation 2, so we get equation 4. Now we want to eliminate z, so we need to combine equations 1 and equation 3. So we get 3x plus 2y plus z equal 3. And then on the bottom, I get negative 6x minus 4y minus 2z equal 1. My goal is to eliminate z, so I'm going to multiply that top equation by a positive 2. When I multiply it by a positive 2, On the first equation, I get 6x plus 4y plus 2z equals 6. And the third equation remained untouched. So that's 6x minus 4y minus 2z equal 1. Notice that here there should be a negative because it remained untouched. So plus and minus, plus and minus, plus and minus. I get 0 equals 7. Is that right? No. So notice that once I get here, if I'm trying to get to equation 5, I get no solution. And if I reach to no solution, I am done. So the answer is there's no solution. There's no solution that exists that will make this system of equalities true. So that means that your system is inconsistent. It's an inconsistent system. Alrighty. So for the next equation is actually a system of linear equations or a system of linear equations that involves applications. And we use this as well in our mathematics courses. And it's important for you. The most difficult thing about application problems is the setup. So it's translating the math and the language together and creating an equation. So let's begin by reading the question. The largest angle in a triangle measures 22 degrees more than 3 times the smallest angle. So they're already talking about a smallest angle, a smallest, the largest, and then there's the middle angle. So the middle angle measures 4 more than the difference between the largest and the smallest. Find the measures of all 3 angles. So notice that they all refer to a measurement of the smallest angle. So they all reference the small angle. So let's begin by identifying some variables. Let the smallest be the variable x, the largest the z, the middle the y. So x, y, z. Now they're saying that the largest, so that means the largest z, measures 22 more than 3 times the smallest. So 3 more, so 3 times more than 22 degrees. So 3 times more than 3 times the smallest angle and 22 degrees more. Now the middle angle, y, what is y saying? The middle angle measures 4 more, so it's 4 more, so addition, the difference between the largest and the smallest. So the largest is z, the smallest is x. And then the last thing is you're trying to find the measures of all 3 angles. So that's x plus y plus z is 180. So the sum of all angles is 180 degrees, which is the triangle. That's how much the triangle measures. So let's keep that in our back burner. So then we have 3 equations and 3 unknowns. So the 3 equations is we already have x that is being solved for, y in terms of x and y, and then of course x, y, z. So notice that what we can do is easily notice that z is in terms of x and y is in terms of x. So we are going to be using the substitution method here. So the substitution method is y is equal to 4 plus 3x plus 22 minus x. So then y is going to be equal to the following. 4 plus 2x plus 22. Let's combine y equal 2x plus 26. So now I have y and I have z in terms of x. So now I'm going to substitute x and y into this equation. So if x plus y plus z equals 180, I can substitute, use substitution method again. So now I have x plus y is in terms of x, so there it is, there's that substitution, plus z, which is also in terms of x, so it's 3x plus 22. Now I have x, 2x, and 3x. I'm going to add, and that's going to be equal to x plus 2 is 3 plus 3 is 6, so 6x plus 22 and 26. So we get 22 plus 26. That gives me a total of 48. It's 180. So then if I solve here by subtract, I get 6x is equal to 180 minus 48. It's 132. Now I have to divide both sides by 6. So 132 divided by 6 will give me the smallest angle. So now that I know what my smallest angle is, which is 22, I can back substitute. So x is 22. Now the middle angle is going to be y equal 2 times 22 plus 26. So if I multiply 2 times 22, that's 44. 44 plus 26, it's 70. So y equals 70 degrees. Notice that all of these are degrees. They do represent angles, so we want to make sure that we are writing them accordingly. And then, of course, the largest, z, is going to be 3 times 22 plus 22. So then 3 times 22, if I multiply 3 times 22, that's 66. 66 plus 22, that's 88 degrees. Now, if I add 88, 70, and 22, that should give me a total of 180. And therefore, you can check that your solution has been verified. So my solution, my order triple, is going to be the point x, y, z. So those are degrees. All righty. The next question of this section is question 7. We wish to find an equation of the form y equal ax squared plus bx plus c that defines a parabola going through the point. Now, it's already saying 1, 9, -2, -24, 3, and -19. So that means we have equations to work with. So we have y is equal to ax squared plus bx plus c. So what we need to do is substitute the first one, 1 and 9, in terms of x and y. So then y is 9 equal a times 1 squared plus b, so b times x, which is 1, plus c. So then this becomes a plus b plus c equal 9. That's going to be my first equation. My second equation, it has to pass through the point -2, -24. So x will be -2, y will be -24. So you have -24 is equal to a times -2 squared plus b times -2 plus c. So this is -24 equal 4a minus 2b plus c. That's my equation 2. My equation 3 is passing through the point 3 comma -19, where this is x and this is y. So it's -19 is equal to 3 squared times a plus 3 times b plus c. So that's -19 is equal to 9a plus 3b plus c. And that's equation 3. So now I'm going to combine equations 1, 2, and 3. A plus b plus c is equal to 9. Then I have 4a minus 2b plus c equal -24. And lastly, 9a plus 3b plus c equal -19. Now this becomes a system of equations. And what I'm trying to do is eliminate a variable. So I'm going to decide to eliminate b. So I'm going to combine equations 1 and 2. So that's a plus b plus c equal 9, and 4a minus 2b plus c equal negative 24. So I'm going to eliminate the b. So I'm going to multiply this first equation by 2. So it's 2a plus 2b plus 2c equal 18. And then I have 4a minus 2b plus c equal negative 24. I'm going to use the addition method here, which is 6a. I'm going to cancel plus 3c is equal to, if I have a 24 minus 18, which is going to be a negative 6 here. So I'm going to be able to clean it up. Now I'm able to, they're all divisible by 3. So if I'm going to divide it, I'm going to simplify it. So it's going to be 2a plus c equal negative 2. That's going to be equation 4. So what I did was I simplified my equation 4, and I'm able to do that. So then I'm going to combine equations 1 and equation 3. So equation 1 and equation 3, a plus b plus c equal 9. And then I have 9a plus 3b plus c equal negative 19. I'm going to multiply the top by a negative 3 because, again, I want to cancel my b's. So I get negative 3a minus 3b minus 3c equal negative 27. The bottom remain untouched, which is 9a plus 3b plus c equal negative 19. I get a positive 6a. My b's will cancel. Minus 2c is equal to, if I have a negative 27 and then a negative 19, I get negative 46. So I'm able to divide both of them by 2. So divide each by 2 to simplify. Equation 5 will be 3a minus c equal negative 23. Now, finally, I can combine equations 4 and 5. So I'm going to combine equation 4 and 5 and cancel c. So 2a plus c equal negative 2, equation 4, and equation 5, just 3a minus c equal negative 23. I get 5a is equal to negative 25. Notice that here I'm able to solve for a, and I get a equal negative 5. So I'm able to solve for one solution. Now I can back substitute into either equation 4 and 5 to solve for c. So that's what I'm going to do. So it's 2a plus c equal negative 2. That means I'm back substituting because I'm solving my system of equations here. So then I get 2 times negative 5 plus c equal negative 2. I get negative 10 plus c equal negative 2. Notice here, this is all pure computation. So c equals 8. So now I have a and I have c. I'm missing b. So I know that a plus b plus c is 9, right? Because that was from equation 1. So let's back substitute, and I get negative 5 plus b plus 8 equal 9. So then I'm going to subtract both sides and solve for b. So I get b is equal to 9 minus 8 plus 5. I get b equal 1 plus 5. That gives me b to be 6. Therefore, I'm able to solve efficiently for a, b, and c. My triple is negative 5, 6, and 8. Now, this is not my final answer because my final answer is actually to write the equation y equal ax squared plus bx plus c. But we already have that solution. We know what a is, we know what b is, we know what c is. So we get y equal ax squared plus bx plus c. So then I get y equal negative 5x squared plus 6x plus 8. And that gives me my full solution. So y equal negative 5x squared plus 6x plus 8. And with that, our solution is this quadratic equation verifies that all of them will pass through the provided points. 1, 9, negative 2, negative 24, and 3, and negative 19.
And with that, we have finalized section 8.2. Thank you, and I'll see you guys next time. Bye-bye.